For Newton, space and time are absolute and independent entities, immovable, everything with a unique address. At each point in time, there is a coordinate of a location, and time is for Newton also absolute. There is a timeline ever flowing in a constant stream forward. If everyone is moving at the same speed, then Newton's laws for motion and gravity actually hold up. The behavior of electricity, magnetism, and light, which did not fit Newton's laws, were then answered by James Clerk Maxwell's four equations. When electricity or magnetism changes, they affect the other. Together, these laws help explain the behavior of light, and therefore light was thought to be an electromagnetic wave. Then waves need something to wave upon. And so scientists postulated that there was something called the light-bearing ether that would eventually be found. It was believed that once found, it would follow Newton's laws, and thus the universe and its laws of physics were explained. Well, now enter Albert Einstein into the picture. He rejected the idea of an ether, and as something as simple as moving a magnet around a coil to create a current would require complex explanations when assuming that there was some type of ether. Instead, Einstein opted for a simpler solution, that all that mattered was the relative state of motion. He then proposed that light moves at a constant speed, and that physics are relative and same for all observers moving at the same speed. This does not mean that the idea of an ether has been entirely given up on, especially with the emergence of measured dark matter and dark energy. The discussion on ether has been revived as an alternate explanation, and at times converging explanation. But Einstein's explanation accounted for different perspectives. For example, when you travel quickly, things appear smaller. And in a similar fashion, the faster you move, the longer a duration of time is when observed by someone at rest. So time seems to dilate when you're moving fast. It was Hermann Minkowski who put these two aspects together and brought forth the idea of space-time, arguing that they needed each other, both space and time needed each other to create existence. And with that, he brought the world into a four-dimensional reality. The next big step would be to move from gravity to acceleration as a concept. Seeing them as essentially the same thing, Einstein could account through this for the weight we are on Earth and the weightlessness we experience in space. He also had to alter the idea that the shortest path for light between 2 points is a straight line. If you are restricted to the surface of something like a sphere, then this path would have to be curved. With these two, he concludes that space-time then is also curved, as this curvature is organized by matter and energy. And this helps us to account for gravitational orbits. It's as if you put a bowling ball on a trampoline, which would then pull down the trampoline. And then if you rolled a tennis ball around that, it would speed up going in and slow down coming out. With the theory of relativity, there is a decided shift from the concrete observations that explained reality in Newtonian physics to one of our subjective perception as unique and reliant upon a universe that has no absolute space, rather one constant that it is the speed of light, and a postulate that existence is made up of energy and matter in motion. So translating this into the social sciences as they adapt it and change it and move it away from actual science, the concept of relativity moves societies from the majority acceptance of a grand narrative with a singular history and purpose towards the acknowledgement of differing pluralistic perspectives. And the tension between these two camps is something that is still a primary concern of today's societies. So let's take a look at, is the Earth inhabited? Relativity also brought with it other perspectives that forced a reevaluation of the predominant hierarchies of the day. This was especially poignant in the late 20s as so-called revolutionary movements like the Nazi Party whipped up emotions of disaffectedness and funneled that anger towards the German Jewish community, who made up of less than half of 1% of the population. The effectiveness of their propaganda campaign has been much imitated wherever a demagogue has sought to undermine democratic forms of governance. And so it isn't surprising to find the Jewish Austrian author Egon Friedel's story on the Earth as it is observed by scientists from another planet, categorizing Earth in a cold, dispassionate manner and making claims of its place within a hierarchy of their own perspective, much as the Nazis did with their pseudosciences that placed them atop this racist hierarchy and the rules for which they themselves were drawing up, putting themselves up there with little basis in fact. The question of whether there is life on Earth is already one we know to be answered from our perspective, so that Friedel presents how the rules for existence are different in different contexts. It is the type of social relativity that he experiments with in this short story. Their planets do not move. They therefore posit that Earth's movement would make it uninhabitable. They consider it too cold for life, never getting above 500 degrees. There is too much oxygen for Cygnians to breathe. There's not enough light, and the planets are too dense and heavy. Only the sun, they conjecture, could make life plausible because it falls within their expectations. But it contains too much iron for it not to be deadly for something like Cygnians. Friedel does allow for a dissenter among the consensus of scientists, who was subsequently disbarred from ever practicing publicly again, a common practice of censoring dissenting voices that speak up against those in positions of power, as pointed out by people like Michel Foucault in his Discipline and Punish. Friedel's career in his own life, Friedel's career was cut abruptly short, though notably, he is one of the only authors ever to offer a sequel to H.G. Wells' The Time Machine, but his work was censored by the NSDAP in 1937 because his works did not conform to the Nazi theory of history. All publishers in Germany and Austria refused to publish his works. And after this humiliating violence and dehumanizing acts suffered in Austria after its annexation by the Nazis in March of 1938, Friedel was ready to escape by any means. And only a few days later, Friedel jumped from his window to his death as 2 SS officers came to arrest him. So in this lecture, we've seen how the social sphere adapts to shifts in the scientific theories that explain how we interpret reality. And these shifts happen in increments throughout history, and it provides us some insight into how we move forward, perhaps with a sense of progress, in that those views that were taboo for science to intervene in suddenly become more accepted. This is the case with our film for this week, Alraune, which was one of the most popular cinematic features of early cinema, as it touched upon the then scandalous experimental practice of artificial insemination. But as this became more accepted, the story was of little interest to audiences and directors, and is now only touched upon as a form of nostalgia. Although a new version of Alraune was made in 2019, there was no mention of her origins, but rather it was another tale that preyed upon the fears of a sexually liberated woman and an indulgent, impotent male, as she is transformed into a type of a mythical creature, a dryad. Well, we'll take a closer look at the 1928 version of this story in our next lecture. Until then. Seems like